Okay, let's look at the Chapter 2 questions, starting with the basic ones of solving equations by factorising. Now, a classic mistake on questions like this would be to divide by x and just say the answer is x equals 4. Whereas instead, what you really should do is subtract 4x from both sides and then factorise, because by dividing by x you are necessarily saying that x can't be 0 because you can't divide by 0. So by factorising it out, you actually see that x can be 0, and by dividing by 0 you are leaving that result out. So factorise these. If you've got one of the more difficult ones, what I would do, where's my calculator? What I would do is factorise this on the calculator by simply putting it in. Essentially this solves it, but if ever you're asked to factorise, you can do it this way. So 2x minus 5, 2x minus 3, that would be the factorised version, and there's no difference really in what you write down if you factorise it using this method or factorising it using the AC method. I just think this is quicker, and you would end up with 5 over 2 or 3 over 2, which is what it says in the calculator. So that's about it. For those with the quadratic formula, it's worthwhile knowing the quadratic formula, because on some of the more complicated questions you'll see that you'll end up using it because there's algebra involved. So when we get to circles, you'll see that in more detail. For the intermediate textbook questions, where we're going on to the completing the square stuff. So some of them are easier. So you remember to factorise out the number at the front. This one's okay because 8 divided by 2 is 4, and then that divides by 2 again, so it's not very awkward. Questions like this are a little bit more awkward. For this one, factorise out the 3 from the first 2 terms, which doesn't really feel like factorising, but it is necessary to have it like that. Then I use square brackets because I don't want to make mistakes. What I used to do was, when it got to the point, let me just get there. When it got to the point where I multiplied back in by 3, I would forget to times this by 3. So the square brackets is my way of reminding myself to times both of these by 3. So minus a third, minus 1, so that would be minus 4 over 3. For the questions like this one, this is more awkward than that, because firstly the leading coefficient is negative and it's 8, and then you have to divide 2 and, well, not 10, but 2 by 8 and then halve that, so it gets more awkward more quickly, especially because there is a negative involved. So what I would do is rewrite that so that it looks like a quadratic, so squared term first, then factorise out the minus 8, so x squared minus a quarter x. Again, I'm using the square brackets so that I don't make a mistake later on. Half of this is an eighth, and then you've got to take away that squared. Multiply the minus 8 back in, remembering to always be careful when you've got especially multiple negatives, and then combine those. This is one of those awkward kind of questions that you might see in a modelling question. I've written mine as fractions, but you could easily see this as, say, 10 and an eighth, take away 8 lots of x minus an eighth as a decimal. And when it looks like this, it may not look necessarily like it's been put into complete the square form, And this is the kind of thing that will happen in those more advanced questions with modelling. Everything about this is the same as it was with a quadratic. It's just more awkward because there's decimals and negative numbers, so it doesn't appear to be the same, but the turning point is still just x is 0.125, y is 10.125, so that is the turning point. It's the negative version of that, so positive 0.125, and then the y coordinate is that. We'll see some more of that when we get to the advanced questions. These next ones are just solving using completeness square. You'll find that when you solve using completeness square, you are essentially just using the quadratic formula. All you do with solving by completeness square is just complete the square and then make x a subject by kind of undoing everything that's been done to x. With these questions, we're just sketching the graph. So remember what we said about the different forms of a quadratic. They each tell you something different about the quadratic. So firstly, in the expanded form, that 8 tells you where it's going to cross the axis. Then if you were to factorise that, so that is going to be x minus 4x minus 2, you can find the roots. Okay, so x is 4 or 2 when y equals 0. These are the roots. Okay, so 4 and 2, let's put them there and here, 2, 4, that one was 8. And then finally, it's the turning point. Now you can find the turning point by completing the square. In this case it's going to be what? X minus 3 all squared minus 9 plus 8. So 3 minus 1. Or you can see that, or if you know that a quadratic is symmetrical around the turning point, then you'll know that the x coordinate's got to be halfway between 2 and 4, which is 3, and then substitute that x coordinate into the original equation and you'll get 3 squared minus 6 threes, so that's 9, take away 18, minus 9 plus 8 is minus 1. So that should be 3 minus 1. A couple of ways of doing that, either completing the square or using the fact that it is symmetrical. So this one, say J, is a little bit more complicated, only because it's got decimals in it. So I will just point out that using the equation tool on the calculator, if I put in these 0.5, 0.2 and 0.02, you're always allowed a calculator, so that's not a problem. You'll get the solutions for the roots, so it says equal to 0. So it's going to cross at negative 0.2. A second. Is that just one solution? Is that a perfect square? So it touches, yeah. So when you solve that one, you're going to get repeated roots. So it's just going to touch the axis and bounce off. But again, these more awkward ones with the fractions or decimals, those are more commonly seen in, say, modelling questions, where things are based on real life, rather than the kind of carefully curated questions where all the answers come out to be nice fractions or whole numbers. With questions like this, where it talks about the number of solutions, this is when we're talking about the discriminant. So 2 real solutions, exactly 1 solution, equal roots, which is the same as exactly 1 solution, or no solutions. These are all based on the discriminant. So 2 real solutions tells you that the discriminant, b squared minus 4ac, is positive, greater than 0. Exactly 1 is when it's equal to 0. Equal roots is the same as above, so equal to 0, 1 solution repeated, and then no solutions or no real solutions is when b squared minus 4ac is negative. So in each of these situations you're going to use the discriminant it's got algebra in it, so you can't just use your calculator to solve it. And you're going to put in b squared, so 6 squared, minus 4 times a, which is 1, times c, which is k. So minus 4k is greater than 0. You rearrange that. I'm going to do it this way so I can point something out, which is when you divide by a negative number in inequality, you have to flip the sign. So if you divide by negative 4 or times by anything which is negative, you have to flip the sign. So k is less than 9 is the values of k for which that's got 2 real solutions. Yeah, with the other ones you do the same thing, but with equal to 0 or less than 0. For the more advanced questions, we're going to start with the pseudo-quadratic equations. So the thing to notice about all of these is that they have a power, half that power, and then no power. And all of these are x to the power of something. So this one x to the power of 1, root x is x to the power of a half, and then no x. X to the 2/3, x to the 1/3, no x. And they all have that in common. A power, half the power, and then no power. So for the first one, you're going to solve it in the same way you would solve a quadratic, whether that is by factorising. So this is going to be 8 and 1. But instead of it being x plus 8 and x plus 1, it's going to be x cubed plus 8, x cubed plus 1. If you were to expand this, you would get that. Then you solve it by making each of these, we're finding the real roots, so that's equal to 0. So either x cubed is minus 8 or it's minus 1. And then there's just one extra step, which is you're always going to end up with x to the power of something, or at least it's not going to be x equals here. So the one final step is to undo whatever's been done to x. So in this case, we're going to cube root our solutions from the first kind of part. So x cubed, cube root that. For the slightly more complicated ones, maybe ones that don't look necessarily like they're quadratic. I mean, they're not quadratic, but pseudo-quadratic. We're going to have x minus 7 and 10, so we're looking for minus 2 and minus 5. And then this, instead of being x, it's going to be root x. So I always remember it as being the middle one. The term which is normally x, whatever that term is, that's what it is. So that means that root x is either 2 or 5, which means that x is that squared, so 4 or 25. If you ever want to check your answer with any solving questions, you can check your answer by substituting what value you got, so let's say 25, into the equation. So 25 minus 7 root 25 plus 10 should equal 0, and that's how you know that you've found a root. It doesn't always have to be x equals. You can see here that we've got 3 to the power of 2x and 3 to the power of x. Now what I said in chapter 1 was that 3 to the power of 2x can be written as 3 to the power of x squared, kind of using that index law backwards. So here the thing that goes in the brackets is 3 to the power of x. And again, it's obvious with these questions what we have to do, hopefully, because they're all about the quadratics. In a test, what you're looking for, because it's going to be mixed in with a load of other things like circles and straight lines and logs and whatever, what you're looking for is a power, half that power, and no power. So 3 terms, power, half the power, no power. So in this case, we're just looking for two numbers which times together to make 27, add together to make minus 28. Those are going to be minus 27 and minus 1. And then the thing that goes here is not x, it's whatever the middle one is. So 3 to the power of x. I mean, that's given to us in the question, but if it's not, you could still be expected to do it. So part B, find the roots. So put that equal to 0 and solve. So 3 to the power of x is either 27 or 1. And then there's that one final step, finding out what x is. In this case, it's easy, you don't need any logs. You just think. So 3 to the power of something equals 27, that's 3. 3 to the power of something equals 1, that's 0. And again, you can put that back into the original equation if you want to check it. I'm not going to bother. Just going to move on to the other more advanced thing, which is modelling questions. You'll see that there's a couple of things which are different from these questions and other quadratics questions. Firstly, you've got this decimals, like awkward decimals. If you want to do anything with this, it would be relatively awkward. That happens with modelling questions because it's based on real life. It's not based on a carefully curated question where there's nice answers. So they make it purposefully awkward. Also, it's not just y and x. Although it says y and x, y means something. Y is the fuel consumption in miles per gallon, and x means something. X is the speed of the car in miles per hour. So when things have a meaning, that also means that they are limited. So whereas normally x can be anything, y can be anything, it's fine. Here, it doesn't make sense for x to be negative because you can't have a negative speed. It would be 0, but it can't be negative, and then also y can't be negative. So you can't have a negative number of miles per gallon. That would mean that you'd burn a gallon and you'd travelled negative distance, which again isn't a thing. So you have to be careful of those limitations and also what the variables mean, because that's what it's going to talk about in the question. A couple of things with any modelling question: if in a part of the question they give you a number, you're going to be substituting that number in. Okay, so for this one, use the model to find two speeds at which the car has a fuel consumption of 32.5 miles per gallon. Fuel consumption is y, so substitute 32.5 in for y. Once you've done that, it's relatively simple because you just solve the equation, and you can use your calculator for that. So if I take away 32.5, 16 take away 13.25, is that negative 16.25? No, not 25, just 5. Just going to check that. Yep. Then just put those numbers into the calculator to solve it. So minus 0.01, 0.975, and minus 16.5. And the two things that are going to come out are going to be the two speeds, 75.7 miles per hour and 21.8 miles per hour. Part B is particularly awkward. I think it's the most awkward one of these. It's completing the square. That's completed the square form. You see there's 1x and it's in a bracket that's squared. Only 3 marks, and it's quite awkward because of all the negatives and fractions. If you follow the steps, you'll get it, but it is awkward. So firstly, take out the leading coefficient as a factor of the first 2. Then complete the square on what's in the middle. Half of 97.5 is 48.75. Let's just check it. Yep. And then I'm going to have to take away 48.75 squared. So 2376.565 plus 16. Then multiply everything in the brackets by negative 0.01. Oh, wait a second, I made a mistake. Where's my rubber? There we go. I put in the plus here. This is a common thing, a mistake that I should know better than to make. When I divided by negative 0.01, I kept that as positive. It should be negative, so that when I expand it out, I get a positive back. That's at 48. What I did, I noticed it was wrong at this point because I knew that the peak should be a positive number, so x should be a positive number. So let's not make that mistake again. 283.765625 plus 16, and then add those together. So, I assume one of the next questions is going to be about the maximum or minimum. So using the answer to part B, find the speed at which it has the greatest fuel efficiency. So greatest Y is when X is 48.75. So these 1 mark questions, normally all you have to do is look at one of the constants. So the maximum fuel efficiency is 39.765625, and that happens when X is 48.75. For D, use a model to calculate the fuel consumption at 120 miles per hour. I assume it's going to be negative, but when you get a number that is a value of X, substitute that in. So minus 0.01 for X is 120 squared plus 0.975 times 120 plus 16, negative 11. So that happens. Common thing in any model question is looking for limitations and looking for things which don't make sense, for things where it's not valid. So at 120 miles per hour, it's just not valid because you get so Y when X is 120 is negative 11 miles per gallon, which doesn't make sense, as I said earlier. One way to understand that before you even get to that point is to, if you get given a quadratic, you can put it into the calculator to solve it, and what the calculator will also do is tell you the roots, right? So when I say solve it, I mean find the roots. So this is 111.8. That is one of the times that Y equals 0. Okay, the other time is at negative 14, which just definitely doesn't make sense because that is that's a negative speed. It will also tell you the 48.75. That's this. It's the maximum point, and the value of Y at that maximum point, which is 39.765625. It's the same thing we got here. So a lot of the stuff can be used and checked on the calculator. I would do that if I were you, because then you know when you've gone wrong. There's a few more questions like that, and then the exam questions, but it's getting quite long as a video. So have a look at Solution Bank for any questions based on the textbook, and have a look at the mark scheme for any of the questions which are based on exam questions. Okay, thanks.